Good day everyone, welcome to another episode on School on Air. My name is Anurapo Peter and I'll be your tutor today for Mathematics Secondary Schools 2. So our topic today is algebraic expressions, polynomials. So daily objectives for today will be definition of polynomials, classification of polynomials and homogeneous polynomials. Definition of polynomials. Polynomials describe an expression of two or more algebraic terms, especially the sum of several terms that contain different powers of the same variables. For example, when we have 2x squared plus x plus 1. So this is a polynomial with three different terms, 2x squared, x, and 1. So for the power, we have variables as x, and the powers as 2, 1, and 0. So, a polynomial, in other words, is an algebraic expression containing more than two terms of different positive powers of the same variable or variables. Like in the case where we have 2x squared plus x plus 1. So that all the powers here are either positive or equal to 0. There's no negative power. So a polynomial can never have a negative power like this. You can never have something like minus 1. Because of this minus 1, everything we're having here is not a polynomial because of this negative power. Now, properties and characteristics of polynomials. The highest power of the variables in a polynomial defines the degree or order of the polynomial. For example, when we have x raised to the power 4 plus 2x raised to the power 3 plus 3x raised to the power 2 minus x plus 5. This is an example of a 4-order polynomial, since we're having the powers as 4, 3, 2, 1, 0. So here, we can see that the powers here, the highest of the powers here is still 4. This is going to make this polynomial to be a 4-order polynomial. Now for the second one, we have 3x raised to the power 5 minus 4x raised to the power 4 plus 2x raised to the power 3 minus x raised to the power 2 plus x plus 3. So here, the powers we have are x raised to the power 5, 4, 2, and 3. We also have 1 and we have 0. So the highest here is 5. So this is an example of a 5-order polynomial. Then a 0-degree polynomial is known as the constant. For example, we have 2x raised to the power 0. 2x raised to the power 0 is 2, which is a constant. So general form of a polynomial order n is an x raised to the power n plus an minus 1 x raised to the power n minus 1 plus an minus 2 x raised to the power n minus 2 up to e raised to the power 0. So here, e raised to the power 0 is the last term as the constant. An x raised to the power n first term, an minus 1x raised to the power n minus 1 second term, an minus 2x raised to the power minus 2 third term, and so on. Then the power of the variable in any term of a polynomial must be positive. As we said before, for example, expression of the type 2x raised to the power 3 plus x raised to the power minus 1 plus x raised to the power minus 2 plus 6 is not a polynomial because of the powers of x, because some of the powers of x are not positive. Here we have the power of x raised to the power minus 1. Minus 1, which is the power, is negative, and x raised to the power minus 2, which is power, is negative. So this is not a polynomial. Then, generally, a quadratic polynomial takes the form of ax squared plus bx plus c. So this is an order 2 polynomial. A quadratic polynomial is an order 2 polynomial. And we have cubic polynomials, which takes the form of ax raised to the power 3 plus bx raised to the power 2 plus cx plus d, and so on. So this cubic polynomial is a 3-order polynomial. Homogeneous polynomials. A polynomial containing two or more variables are said to be homogeneous if every term is of the same degree. So for example, where we have xy raised to the power 2, x raised to power 2y and 3x raised to power 3. This is a homogeneous polynomial of order 3, as we're having x raised to power 1, y raised to power 2. So sum of all the powers here, 3. X raised to power 2, y raised to power 1. Sum of all the others here, 3. Then x raised to power 3. Sum of all the others here also 3. So this is a homogeneous polynomial of order 3. Then we have x raised to 3x plus 2y minus 4z. This is a homogeneous polynomial order of 1. So you have 3x raised to power 1, 3y raised to power 1, 4z raised to power 1, all of powers of 1. So let's take a few examples. So the question here is, which of the following are homogeneous, and we should state the degree of those that are homogeneous. Zx plus xy. Now the equivalent form for this expression is z raised to power 1, x raised to power 1 plus x raised to power 1, y raised to power 1. So this is going to make it a homogeneous polynomial to the order of 2, since the sum of all the powers here 2, sum of all the powers here also 2. Then the second example, we have a squared b squared plus 2a plus 2b. The equivalent form for this is a squared b squared plus 2a raised to power 1, 2b raised to power 1. Now if you look at this, the power for total, the sum of all the powers for a squared b squared is going to be 2 plus 2, that's 4. While for 2a raised to power 1 is 1, 2b raised to power 1 is also 1. So you see that we have the powers as 4, 1, 1, which are different. So this means that this polynomial is not a homogeneous polynomial. So these are exercises that will help you to understand the topic better. So yeah, which of the following are homogeneous? State the degree of those that are homogeneous. First one, AB plus AC plus BC. Second, 6x minus 5y plus 6z. Question 3, x raised to power 3 plus yq plus zq plus 3a squared c plus 3ac squared. And the fourth, 5x cubed plus 6x squared y minus 7xy squared plus 6y cubed. In summary, the highest power of the variables is the power of the polynomial. The general form of the polynomial is an x raised to power n. The first term, an minus 1x raised to power n minus 1, second term, an minus 2x raised to power n minus 2, third term, up to the last term, which could be a constant, as a naught. The power of the variable in any term of a polynomial must be positive. Homogeneous polynomials have all the terms to be of the same degree. This is the end of today's unit. I hope you enjoyed the class. See you in the next class. Thank you for watching.